Hi, AP Physics. In this video, I'm going to be helping you understand the capacitance of concentric spheres. So our setup is going to look something like this. We are going to have a sphere with a radius of A, and another sphere on the outside, more like a shell, that's going to have a radius of B. The inner sphere is going to have plus Q, and the outer sphere is going to have negative Q. So if we want to find the capacitance, let's always write down our equation. So capacitance is defined as the charge over the change in voltage. Okay. Now we don't know what the change in voltage is, so that's going to be our first step. So the change in voltage is going to be equal to negative integral of the electric field dot product with some small change in position. Now, the electric field is pretty simple because the electric field is always going to be moving radially away, right? We have radial symmetry with our spheres. So we can write out that electric field as KQ over R squared. And we can plug that into our integral. So we get negative K, and this Q isn't changing, right? So we can pull it out of the integral. Integral of D, we're going to change it to R because the electric field is going to be moving radially outwards with our radius. And we're actually evaluating the integral with specific bounds, right? From A to B. I should include that here. Then, once we have this, we're ready to do our integral. When we have 1 over R squared, we should be pretty familiar that this is now equal to a negative 1 over R. So we can actually get rid of our negative out front. So it's going to be KQ 1 over R. And we're going to be evaluating this at bounds A and B. We'll put this in a box over here so that I can separate it. Once we do that, we plug it in. We get KQ 1 over B minus 1 over A. And it'll be nice if we can put this in one term. So we will cross multiply. So that is going to be KQ A minus B over AB. Sweet. So this is equal to our change in voltage. Now, let's go back to our capacitance equation. So this is going to be Q, and now underneath is going to be KQ with our value here. And something that the book talks about is that the delta V, actually, let me go back. The delta V is actually the absolute value. So that's going to change our sign. So C equals Q over the absolute value of VB minus VA. So what this does is it's going to switch the sign on our A and our B there. So it's going to be B minus A. So it's going to be Q over KQ. And then it's going to be B minus A. That absolute value switches it around. And divided by AB. So our Q's cancel. And then we can flip this since we're dividing but with a fraction. So it's going to be AB over K, B minus A. And that is the capacitance of concentric spheres.